All right, let's get right into it. Imagine you're trying to frost a cake, but you haven't actually baked it yet. It's just a bowl of batter. The result? A complete mess, right? Well, in software development, and especially in iOS, we run into this exact kind of problem all the time, getting our code to run in the right order. Today, we are going to master the elegant solution to this: operation dependencies.
So, be honest. Have you ever been there? You write some code to fetch data from a server. Then you need to process that data and then, finally, display it. But what happens? Your app tries to display the data before it's even finished fetching. It's such a classic and frustrating problem that leads to crashes and some really weird bugs.
And look, if this has happened to you, you are so not alone. This is one of the biggest challenges in concurrent programming. When you have multiple things happening at once, how in the world do you make sure that the really critical steps happen in the right sequence? You know, modern apps have to be super fast and responsive, so we run tasks at the same time, concurrently. But here's the catch. Not everything can happen at once. Think about it. Processing an image has to wait until that image is actually downloaded. That right there is the core of the concurrency challenge that we're going to solve.
Because when we don't control this sequence, what we get is just chaos. This is where you stumble into those infamous race conditions, where two tasks are basically fighting with each other, leading to totally unpredictable behavior and bugs that are a nightmare to track down. It's a digital version of that messy, unbaked cake.
So how do we bring some order to all this chaos? Well, it turns out Apple gave us this beautifully simple tool for it: operation dependencies. This is how we tell our code very clearly exactly how it needs to behave. So what is it really? Let's get the official definition straight. An operation dependency is basically a rule you set up between different tasks or operations inside an NS operation queue. It's just a formal, clean way to say, hey, this needs to happen before that.
And the logic behind it is incredibly straightforward. All we're doing is telling Operation B, hey, hold up, you cannot start your job until Operation A is 100% finished. It's kind of like a baton pass in a relay race. The second runner can't take off until they get that baton from the first runner. Simple as that.
All right, so theory is great, but let's see how this actually works in the real world. It's time to check out some code.
And here it is. It looks simple, but this little snippet is so powerful. We've got two operations. Op1 fetches data, Op2 processes it. And then, you see that last line? That's the magic. That one single command enforces our entire sequence. No complex nested callbacks, no messy state tracking variables, just one line.
Let's just break this down real quick. We set up our two tasks, Op1 and Op2, but the absolute key here is that third line, op2.addDependency op1. With that one command, we're telling the whole system that op2 isn't even eligible to run until op1 has finished completely. It's declarative. We just state the relationship we want, and we let the system figure out the how. That's what makes it so powerful.
Now, of course, like any powerful tool, there are a few rules you have to follow to use it right and avoid, well, shooting yourself in the foot. So let's go over the essentials.
Okay, 3 really important things. First, a dependency only pauses the specific operation it's on. It doesn't freeze up the entire queue, which is awesome for keeping your app responsive. Second, you can build really cool long chains. C depends on B, which depends on A. And third, and you have got to burn this one into your brain, you must avoid circular dependencies. This isn't a suggestion, it's a critical rule.
And this slide illustrates that point perfectly. On the left, you've got a safe, clean chain. A runs, then B, then C. Predictable, logical. On the right, total disaster. B is waiting for A to finish, but A is also waiting for B to finish. They are going to wait for each other forever. That's called a deadlock, and that part of your app will be frozen solid. To your user, the app just looks broken.
So, after all that, why does this really matter? Why should you care? Well, it all comes down to writing professional, reliable, and just plain solid code.
The payoff here is huge. You get to build clean, logical workflows that are actually easy to read and debug. You can say goodbye to that pyramid of doom you get with a bunch of nested completion blocks. You guarantee a predictable order, which just wipes out race conditions. Honestly, this built-in dependency management is the killer feature of NS Operation Queue. It's the main reason you'd reach for it over a more basic tool like Grant Central Dispatch when you have a complex series of tasks to manage.
So I'll leave you with this final thought. Think about an app you're working on right now. I bet there's a messy, complicated, multi-step process in there that just feels fragile.
So what's a complex task in your app that you could simplify and make rock solid, maybe even today, just by using the power of a simple dependency?